Hi friends, welcome to follow up. In this video, we are going to have a look at today's daily challenge problem 129, sum root to leaf numbers. This problem can be solved by traversal. Our plan will be the following. First, we're going to look at the problem statement and then analyze the method, and then we are going to do the coding. So here we are given a binary tree, and each node in the binary tree contains digits from 0 to 9. So each root to leaf path in the tree represents a number. And for example, here we have 1, 2, so this will be 12. So here we have 1, 3, this will be 13. So we want to return the total sum of all root to leaf numbers. So here a leaf node is a node with no children, right? So in example 1, so you can see that the return is 25, which is the sum of 12 plus 13. And in example 2, so we have 3 leaves. In other words, we have 3 root to leaf paths. So one is 495, and the other is 491, and the other is 40, right? So you add them together, you get 1026. So here the constraints are the following. The number of nodes in the tree is bounded above by 1000. And also, the tree is not null. So noticing this point that the tree is not null actually has something to do with the coding format. And the nodes contain values that are digits. So the depth of the tree will not exceed 10, right? So in other words, so here you can do a very rough estimate. Assume you have 1000 leaf even, right? In practice, it should be less, right? So you times 10. So that this is at most 10,000 nodes we need to traverse. So with that said, basically the key point for this problem is how to retrieve or record the root to leaf numbers, right? So this actually can be very simple. So each time you do the traversal, you are going to record the value up to that node. For example, in example 2, at the very beginning you get 4, right? Then you are going to traverse to the children of this node. For example, 9. So when you do 9, what you are going to do is actually 4 times 10 plus 9, right? Then if you continue, so to do the traversal up to the children for 9, for example 1, right? You are going to get this number in total is actually 49. But if you go one level deeper, it corresponding to push the number to the left in digits. It's corresponding to multiply by 10. So you get 49 times 10 plus 1. That is 491. By this way, you can record each value from the root up to that node. And then you just need to check if the node is a leaf node. Then you just add to the result. So with that said, we are ready to write the solution. First, let's initialize a result variable. So this is an integer. So its final state is what we want to return. And then we can do the traversal. So you can choose to use whatever traversal order you want. So here we can use depth-based. So we have a root, and then we have root value. The reason we can write this line of code is due to the fact that the number of nodes in the tree is at least 1, right? So in other words, this is legitimate. So then we can do the traversal, ls. Then we can get the current node and the value. So it's s pop, right? And then what we want to do is to check if this node is a leaf node. If it's a leaf node, we need to add the value to the result. So if, not node left and not node right. So it means that we are arriving at a leaf node. Then the corresponding recording value will be the one we need to add to the result. The result add this value. Then we consider to traverse left and right subtree. So here I first do right subtree. If a node are right. So what we are going to do is that s append. So the node, right, that is the root node right, and the value will be 10 times the previous value plus node right value. So this is the one. And then we do the right subtree. Then as we're going to have s append, so node left subtree, and then 10 times the previous value plus node left value, right? So here the order for traversal, like you do left, so here is left, left or right, it does not matter. But if you do right first, it corresponds to pre-order traversal of binary tree. So after we exit this while loop, so we are going to find the final answer for this problem. We just need to return the result stage. So with that said, basically we finished the coding part. So before we move forward, let's do a test. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes all the cases. So here I would comment that this is just one way of writing the solutions. So there are some extensions. For example, you can try to use, so here if you put it as a queue, so it's corresponding to right the first traversal. And also you can try to write some recursive format. So I guess with that said, that's about it for the current video. Thank you for watching.